Why this plastic island will kill all fish? The Great Pacific Garbage Patch is situated between Hawaii and California, covering an area about the same size as the country of Iran. For more than half a century, the GPGP has been accumulating plastic waste, which mostly originates from 5 countries: China, Taiwan, Japan, South Korea and the US. It is commonly called a trash island, but the Ocean Cleanup Organization defines it as a soup, because its concentration of plastic varies drastically between areas with hundreds of kilograms per square kilometer, called hotspots, and less dense areas with only 10 kilograms per square kilometer. It was discovered in 1997 by Captain Charles Moore, who was on a voyage from Hawaii to California when he spotted a continuous flow of plastic debris floating in the ocean. It was then that he stumbled upon what we now know as the Great Pacific Garbage Patch. In 2012, researchers at Scripps Institution of Oceanography at UC San Diego collected and analyzed samples from the North Pacific Gyre, including the Great Pacific Garbage Patch, to characterize the types and distribution of plastic debris. They found safety helmets, plastic bags, bottle caps, plastic water bottles, and styrofoam cups. They then calculated how much debris was in the ocean, and they concluded that the patch contained over 1.8 trillion plastic pieces, with an estimated weight of 100,000 tons. So have scientists been researching how this could lead to the demise of fish and seabirds? In a hostile environment where there are about 1.5 pieces of plastic for every fish, life gets harsh for all marine life. Approximately 1 million seabirds and over 100,000 fish die every year because of plastic pollution, and this statistic has grown explosively. But why do seabirds die of plastic? Back in the swinging 60s, less than 5% of our feathered friends had plastic in their bellies. Fast forward 2 decades and that number skyrocketed to over 80%. If we keep up this trend, by 2050, it's predicted that practically all seabird species, a whopping 99%, will be chewing down plastic. Now, imagine you're a baby bird, eagerly waiting for dinner, but instead of a tasty treat, your parent brings you a mouthful of plastic. Not exactly what you had in mind, right? Sadly, this mix-up happens more often than we'd like to think. Even diving birds, like our adorable puffin pals, aren't safe from gobbling up plastic. While surface-feeding seabirds are at higher risk of ingesting plastic, diving seabirds like puffins have also been discovered with plastic in their stomachs. But hold on to your feathers because it doesn't stop there. From seagulls to puffins, birds across the board are making use of marine debris in their nests. Picture this: fishing lines tangled up with seaweed and twigs. It's a sad but true tale of how our trash finds its way into even the most unlikely places. But why do fish eat plastic? Imagine a tiny world where even the smallest beads, less than 5 mm in size, cause big trouble. That's where microplastics come in, sneaky little things that fish mistake for tasty snacks. But here's the twist. Recent studies suggest they might be using scent to trick their prey. It's like a fishy version of looks good, smells good, must be good. Now let's talk about anchovies. They're not just a pizza topping, they are vital players in the ocean's food chain. Munching on krill, they become a buffet for a variety of sea creatures, from larger fish to majestic whales and even us humans. But here's the kicker: plastics don't stop with the fish that eat them. They hitch a ride up the food chain, as seen with endangered species near Tasmania. Scientists found plastic in them, likely from consuming smaller fish that ingested plastic. So, are we inadvertently dining on plastic too? From ocean to dish, tracing the path of plastic into our fish. Fish consuming plastic are now being sold increasingly in supermarkets. The pressing question now isn't whether we're ingesting plastic through seafood, because the answer is a resounding yes. Instead, scientists are urgently seeking to determine the extent of it on our health. Though most of the plastic found in fish resides in their digestive tracts, and it is typically removed before consumption, certain studies caution that microplastics, especially at the nanoscale, might migrate from the gut to the flesh. This is particularly concerning as some small fish and shellfish are consumed whole. There's mounting concern about toxins seeping into these tissues, as laboratory experiments have demonstrated the accumulation of chemicals linked to microplastics in marine animal tissues. A report from Ellen MacArthur Foundation estimated that, by 2050, the volume of accumulated plastics in the ocean will be greater than that of fish. New home marine lives adapt to plastic contamination. Plastic debris congregating in a colossal garbage patch in the Pacific Ocean has become a haven for peculiar blends of coastal and marine species. This unusual amalgamation could heighten the risk of biological invasions, potentially causing chaos in neighboring ecosystems. In a recent study, scientists examined species inhabiting slightly over 100 pieces of plastic retrieved from the Great Pacific Garbage Patch, an area in the northern Pacific Ocean where currents converge, depositing an estimated 79,000 metric tons of plastic debris. The researchers discovered a total of 484 invertebrates representing a diverse array of species residing on the plastic fragments. Surprisingly, many of these creatures typically inhabit coastal regions of the Western Pacific. Among the coastal species identified were birozoans, jellyfish, sponges, worms, and various other organisms. The study co-author says, quote, "I just remember the first time Jim and I pulled out a piece of plastic and saw the level of coastal species present. We were just blown away." Another statement he made is, quote, "We are witnessing frequent interactions between these species on debris, effectively establishing new communities in the open ocean." An effort to correcting one of humanity's biggest mistakes. In what regards cleaning the plastic debris from the ocean, there are many associations and startups developing new technology to clean up what we have been dumping in the ocean for decades. One such example would be the Ocean Cleanup Organization, which represents a beacon of hope in the battle against ocean plastic pollution. Through innovative technology and strategic deployment, the project aims to confront the monumental change of cleaning up our seas. Their mission is to rid the world's oceans of plastic, by cleaning up what is already out there and by stopping what is making its way to the sea by way of rivers. The drawbacks. Firstly, ocean plastic has the propensity to persist in sea surface waters due to its buoyancy. Once introduced into the marine environment, buoyant plastic can be transported by surface currents and winds, eventually accumulating in offshore regions like the GPGP. Furthermore, the GPGP serves as a convergence zone for substantial ocean plastic sources, particularly from Asia, facilitated by ocean currents like the Kuroshio Extension Current System. The relatively high concentrations of plastic in this region are thus influenced by inputs from both local and distant sources. Moreover, the study emphasizes that while global plastic consumption has surged in recent years, a significant portion of produced plastic serves an ephemeral purpose and is rapidly converted into waste, contributing to the influx of plastic debris into marine environments. Overall, the combination of persistent plastic properties, intensified fishing activity, global plastic consumption trends, and oceanic currents converging in the GPGP region contributes to the accelerated accumulation of plastic debris in this area. Understanding these factors is crucial for developing effective strategies to mitigate ocean plastic pollution and protect marine ecosystems.